What if I told you that some of the deepest secrets of the universe weren't discovered in a high-tech laboratory, but were written down thousands of years ago in ancient texts? It sounds like something out of science fiction, doesn't it? The idea that civilizations long gone might have understood the fundamental nature of reality in ways we're only just beginning to grasp today. This isn't about aliens or lost technologies in the traditional sense. It's about something even more profound. It's about the possibility that written within some of the world's oldest spiritual and philosophical works, there might be descriptions of concepts modern science is still wrestling with. Concepts like antimatter, the elusive counterpart to everything we see around us. When we think about antimatter, it feels like the stuff of cutting-edge physics, something that belongs in particle accelerators and theoretical equations. But what if that knowledge wasn't new at all? What if it was hidden in plain sight, coded into poetry, metaphor, and spiritual insight? That's the incredible premise we're going to explore together. The Vedic Scriptures, ancient texts from India that date back thousands of years, contain passages that seem to describe reality in ways that are startlingly similar to how physicists talk about the universe today. Not in technical terms, of course, but in a language of duality, balance, and fundamental forces. This journey isn't just about decoding ancient texts, it's about rethinking what we know about human knowledge, history, and our place in the cosmos. It asks us to consider whether wisdom about the universe has been accessible to humanity across ages, expressed differently but pointing toward the same truths. So if you've ever wondered whether there's more to these ancient writings than myths and rituals, you're in the right place. Together, we're going to look at what the Vedas might reveal about antimatter, why that matters, and what it could mean for our understanding of both science and spirituality. This is a story of mystery, discovery, and the astonishing idea that the keys to the universe might have been with us all along. To truly appreciate the potential connections between these ancient texts and modern concepts like antimatter, we first need to understand what the Vedic Scriptures actually are. Originating in the Indian subcontinent, the Vedas are not merely books. They are considered Shruti, which translates to that which is heard. This signifies a profound belief that they are not human inventions but eternal truths perceived by ancient seers or rishis in deep states of meditation. Their composition is dated over a vast period, with the oldest hymns of the Rig Veda likely composed orally around 1500 to 1200 BCE, though traditional accounts place their origin far earlier. This was an era long before modern instruments, yet the insights contained within these works have sparked curiosity for millennia. The structure of the Vedic corpus is intricate and expansive, often visualized as a tree with deep roots and many branches. At its core are the four primary Vedas. The Rig Veda is the oldest and most revered, a collection of over 1,000 hymns dedicated to various deities and natural forces, exploring cosmology and the nature of existence itself. The Yajurveda is more practical, consisting primarily of prose mantras and rituals used by priests during ceremonial sacrifices. The Samaveda is almost entirely derived from the Rig Veda but set to intricate melodies. It is the root of Indian classical music and was chanted for its vibrational power. Finally, the Atharvaveda is distinct, containing spells, charms, and incantations for everyday life, alongside profound philosophical speculations that often feel the most connected to investigating the tangible world. But the knowledge doesn't stop there. Each of these four Vedas gave rise to a vast body of supplementary literature, creating a comprehensive library of ancient thought. Think of the Vedas as the foundational theory, and these additional texts as the practical applications and deep dive explorations. The Brahmanas are extensive ritualistic commentaries explaining the how and why of ceremonial procedures. The Aranyakas, or forest texts, were for hermits and ascetics, moving the focus from external ritual to internal, meditative contemplation. This line of inquiry culminates in the Upanishads, which are the philosophical crown jewels of the Vedic tradition. It is here that we find intense questioning about the ultimate nature of reality, the self, and the universe, discussions on Brahman, the ultimate reality, and Atman, the individual soul. Later texts like the Puranas and the great epics, the Mahabharata and Ramayana, popularized these deep philosophical concepts through engaging narratives, myths, and stories, making them accessible to everyone. The credibility of the Vedas doesn't stem from their age alone, but from the sheer depth and consistency of the philosophical system they built. This wasn't a primitive or superstitious worldview. It was a sophisticated and coherent framework for understanding consciousness, matter, energy, and the very fabric of space and time. They approached these mysteries not through experimentation, but through meticulous observation of the external world and, more importantly, through profound inner exploration. This established a tradition of inquiry that sought to map the laws of the universe, both seen and unseen, making them a legitimate source of ancient scientific and metaphysical knowledge that we are still learning to decipher today. So, to grasp what these ancient texts might be hinting at, we need a clear picture of what modern science actually says about this exotic substance. The story of antimatter begins not in an ancient forest, but in a 20th century university with a theoretical physicist named Paul Dirac. In 1928, Dirac was working on an equation that would marry the new theories of quantum mechanics with Einstein's special relativity, aiming to describe the behavior of electrons moving at incredibly high speeds. His math was brilliant, but it produced a strange and unsettling result. His equations insisted that for every particle of matter, like an electron, there must exist an identical twin with an opposite electrical charge. This was deeply puzzling because at the time, no such twin had ever been observed. Dirac himself was initially hesitant, even suggesting this mysterious twin might be the proton, but that didn't fit. It was other scientists like Carl Anderson who confirmed the theory's prediction just a few years later. In 1932, while studying cosmic rays, Anderson observed a particle that behaved exactly like an electron, but it curved the wrong way in a magnetic field. It had a positive charge instead of a negative one. He had discovered the anti-electron, which he aptly named the positron. Dirac's seemingly troublesome mathematical quirk had revealed a fundamental truth about our universe: matter has a mirror image. Think of it like this: if you could hold an electron in one hand, its antimatter counterpart, the positron, would look and feel exactly the same in terms of mass, but it would be its perfect opposite in charge. It's a cosmic symmetry written into the very laws of physics. This leads us to the most dramatic property of antimatter: annihilation. When a particle of matter meets its antimatter twin, they don't just bump into each other, they completely obliterate each other in a flash of pure energy. It's the ultimate cancellation. Their combined mass is converted directly into energy following Einstein's famous formula, E equals mc squared. This isn't a slow burn, it's an instantaneous and 100% efficient conversion. To visualize it, picture two tiny, shimmering orbs of light, one representing matter and the other antimatter, flying toward each other. The moment they touch, they vanish, replaced by a brilliant burst of gamma-ray photons. This is the incredible power that makes antimatter so fascinating to scientists and to science fiction writers. It's the most potent energy source known to physics. Yet, for something so powerful, it's also incredibly elusive. One of the biggest mysteries in cosmology today is why our universe appears to be made almost entirely of matter. According to the Big Bang Theory, matter and antimatter should have been created in equal amounts. If that were true, they should have entirely annihilated each other in the early universe, leaving behind nothing but a sea of energy. The fact that we and everything we see exist is proof that something tipped the scales. Some tiny asymmetry, some law of physics we don't yet fully understand, allowed one particle of matter to survive for every billion annihilations. That tiny fraction is what built our entire cosmos. So when we talk about antimatter, we're not just discussing a curious particle, we're touching on one of the deepest unresolved questions about our own existence. Now, to see where this extraordinary idea of ancient knowledge might lead, we have to step into the vast and intricate worldview of Vedic cosmology itself. This is not a simple, flat Earth under a dome of stars. It's a breathtakingly complex and multidimensional model of existence that operates on scales almost too vast to comprehend. At its heart is the concept of cyclical time, a universe that breathes in and out in an endless rhythm of creation, preservation, and dissolution. Unlike the linear arrow of time we're familiar with in the West, Vedic time is described in great cycles called kalpas. A single kalpa, often analogized to a single day in the life of the creator god Brahma, lasts for 4.32 billion of our years, and his night is just as long. This cycle of activity and rest repeats for the entire lifespan of Brahma, which is 100 of his years, a time span so enormous it challenges our very ability to conceive of it. Within these immense cycles are smaller, repeating ages known as yugas. Think of them as the seasons of a cosmic year. There are 4 yugas, each with its own distinct spiritual and moral character, much like the shifting qualities of spring, summer, autumn, and winter. We start with the Satya Yuga, a golden age of truth and perfection where humanity lives in harmony with divine law. This gradually descends into the Treta Yuga, then the Dvapara Yuga, and finally we arrive at the Kali Yuga, the age we are said to be in now, an era of conflict, spiritual ignorance, and discord. But this isn't a one-way slide into darkness, it's a cycle. After the Kali Yuga completes, the cycle begins anew with another golden age. This notion of a universe undergoing perpetual, rhythmic renewal is strikingly similar to some modern cosmological models, like the conformal cyclic cosmology proposed by physicist Roger Penrose, which suggests our universe might be just one in an endless series of Big Bangs. The scale of creation in these texts is equally staggering. The universe isn't a singular entity. It is one of countless bubbles or brahmandas, each emanating from and contained within the body of the divine. The texts describe these brahmandas as egg-like spheres, each with its own layers of elemental coverings and its own inner solar systems, all governed by their own laws and timelines. A single breath of the Mahavishnu, the supreme expansive aspect of the divine, is said to exhale innumerable such universes into existence and inhale them back again. This isn't just one universe, it's a multiverse, a concept that has moved from the fringes of theoretical physics into serious mainstream consideration today. The idea that our cosmos is just one tiny bubble in a frothing ocean of universes is a direct parallel to the Vedic description of countless brahmandas floating like atoms in the infinite. And what is each universe made of? The Vedic seers didn't have particle accelerators, but they developed a sophisticated theory of matter based on fundamental vibrations and elements. They described the entire manifest cosmos as emerging from Shabda, or primordial sound vibration, the cosmic arm. This vibration differentiates into the Panchabhutas, the 5 great elements. These aren't elements in the periodic table sense. They are states or densities of matter, each more subtle than the last. It starts with Akasha, often translated as space or ether, the field from which everything emerges. From Akasha comes Vayu, the gaseous principle of air and motion. Then Tejas, the fiery principle of plasma, light and energy. Next Apas, the liquid principle of flow and cohesion. And finally Prithvi, the solid principle of earth and matter. This is a process of condensation, from the most subtle ethereal vibration down to the gross, tangible solidity of the world we touch. This entire framework presents a universe that is alive, conscious, and vibratory in its very essence. Matter isn't seen as dead or inert. It is condensed spirit, energy slowed down into form. The parallels to modern physics are, at the very least, thought-provoking. The Big Bang theory describes a universe erupting from a singular point of infinite density, expanding and cooling to form particles, atoms, and eventually galaxies, a movement from an undifferentiated state to structured complexity, not entirely dissimilar to the emanation from Akasha to Prithvi. The modern quantum field theory tells us that what we perceive as solid particles are actually excited states of an underlying, invisible quantum field, vibrations in a fundamental medium. This echoes the Vedic idea of a universe born from sound, a vibrational field of Shabda Brahman. It suggests that these ancient seers, through deep internal inquiry, may have arrived at a conceptual understanding of reality that aligns, in a poetic and metaphorical language, with the frontiers of what science is discovering today. They weren't measuring particles, but they were mapping the very nature of existence itself. This brings us to a pivotal and remarkably sophisticated concept within Vedic thought, the idea of prana and its lesser-known but equally vital counterpart. To understand the universe's energetic blueprint, we must move beyond the 5 elements and into the force that animates them. Prana is far more than just the breath. It is the universal life force, the fundamental energy that permeates all of creation. It is the conscious intelligence behind every function, from the spin of a galaxy to the beating of a heart. The ancient seers described networks of these subtle energy channels called nadis and vortices of concentrated prana known as chakras, mapping an intricate energy body that mirrors and sustains the physical one. Prana is the animating principle of all matter, but the Vedic worldview is one of perfect balance and duality, a dynamic dance of opposites that creates the illusion of a stable reality. For every force, there must be an equal and opposite force. This is where the concept of its mirror image emerges. If prana is the force of integration, cohesion, and life, then its opposite is the force of disintegration, separation, and dissolution. While the term anti-prana isn't explicitly used in the oldest texts as a single, branded concept, the principle is described with stunning clarity through various complementary pairs. The most direct expression is found in the interplay between prana and apana. Within our own bodies, prana is the upward moving, vitalizing energy governing inhalation and higher cognitive functions. Apana is its necessary opposite, the downward moving, eliminating force that governs excretion and the body's cleansing processes. One cannot exist healthily without the other. They are locked in a crucial, balancing partnership. This duality is expanded to a cosmic scale in the interplay between the devas and the asuras, the divine and the demonic forces. These are not merely characters in mythological stories. They represent fundamental cosmological principles. The devas embody the centripetal, organizing, and light-giving aspects of prana, the forces that build, sustain, and create order. The asuras represent the centrifugal, chaotic, and entropic aspects, the forces that break down, challenge, and ultimately clear the way for new creation. One is not good and the other evil in a simplistic moral sense. Both are essential for the cycle of the universe to continue. The devas cannot create anew without the asuras first dissolving the old forms. This is a profound echo of the matter and anti-matter annihilation process, where the destruction of 2 particles clears the stage for a massive release of pure energy, the potential for new creation. This cosmic balance is maintained through a constant dynamic tension, much like the delicate asymmetry that allowed our matter-dominated universe to form. The texts describe this equilibrium as Rita, the cosmic order, or later as Dharma, the universal law that sustains harmony. The interaction of these opposing forces, the life-giving and the dissolving, is what prevents the universe from either flying apart into chaotic entropy or collapsing into a stagnant, unmoving singularity. They are the two hands of the divine, one building up and the other breaking down, working in concert to weave the fabric of reality. The annihilating meeting of matter and antimatter is not a flaw in the universe's design, it is the engine of its transformation. Similarly, the Vedic vision sees the interplay of prana and its opposing force not as a battle to be won, but as a dance to be mastered, the fundamental rhythm that keeps the cosmos breathing, expanding, and living. But this intricate understanding of cosmic duality wasn't just philosophical speculation. It was built upon a foundation of breathtakingly advanced mathematics. The intellectual rigor of the Vedic seers is perhaps most clearly demonstrated in their mathematical and astronomical achievements, which were so precise and forward-thinking that they seemed to defy the technological limitations of their time. Their numerical system alone was revolutionary, giving the world the concept of zero and a place value system that we still use today, but they went far beyond basic arithmetic. The texts are filled with calculations of staggering scale, dealing with numbers so vast they approach the infinite. In the Lalitavastara Sutra, for instance, the Buddha is challenged to name all the numerical denominations beyond the everyday, and he proceeds to list names for numbers up to 10 to the power of 53. That's a 1 followed by 53 zeros, a number so large it dwarfs the number of atoms in our entire planet. This fascination with the immense wasn't just for show, it was deeply integrated into their cosmology. Time itself was measured in these mind-bending units. The duration of the 4 yugas, for example, was given as a precise 12,000 divine years, but these weren't human years. A single divine year equates to 360 human years, making the full cycle an astonishing 4.32 million years, and that's just the smallest complete cycle. They calculated the orbit of the moon, the relative periods of the planets, and even the precession of the equinoxes with an accuracy that would not be matched in the West for millennia. Their value for the length of the solar year, for instance, was 365.258,756 days, a figure that is remarkably close to our modern calculation. This wasn't guesswork, it was the product of meticulous, long-term observation and a highly developed mathematical tradition. The question then becomes, why did they need such sophisticated math? It wasn't for building bridges or calculating taxes. It was to map the cosmos itself. Their mathematics was the language they used to describe the architecture of reality, from the cycles of time to the nature of the soul. In the Vedas, numbers often held symbolic and metaphysical significance. The number 1 represented Brahman, the absolute reality. 2 represented duality, the fundamental pairing of spirit and matter, Purusha and Prakriti. 3 represented the 3 gunas, the qualities that constitute all of material nature. This system of sacred mathematics, or Vedic Ganita, was a way to encode profound truths about the universe into a structured, comprehensible form. The precise calculations for planetary motions and cosmic cycles were, in a sense, the source code for their model of existence. It's within this context that we can start to look for hints of something even more extraordinary. If their mathematics was a language for describing physical and metaphysical reality, could some of these vast numbers and ratios be indirect references to the fundamental constituents of that reality, including its shadow counterpart? For instance, some scholars point to the constant appearance of specific, large numbers in descriptions of creation. The Bhagavata Purana describes the total material elements as comprising 24 in the second, combined with another set of factors, creating a specific, vast quantity. While not a direct one-to-one correlation, the sheer scale of these numbers moves far beyond mythology and into the realm of quantitative cosmology, dealing with amounts that are necessary when discussing the fundamental building blocks of a universe. The concept of pairing and symmetry, so central to their philosophy, is also deeply mathematical. The idea that for every unit of creation there is an equal unit of dissolution could be expressed numerically. If the number of atoms in the universe were x, then the principle of balance would suggest a need for a corresponding value, perhaps even an anti-x, to maintain cosmic equilibrium. The mathematical frameworks they developed to handle astronomical scales and cyclic time were precisely the kind of tools one would need to even begin to conceptualize the quantities involved in a matter and antimatter universe. They were thinking in terms of whole system accounting for the cosmos, not just isolated parts of it. Their math provided the vocabulary to discuss the totality of creation and the balanced, opposing forces that must exist within it to prevent it from collapsing into nothingness. This sophisticated numerical language may have been their way of pointing toward a deep truth about the universe's substance, a truth that we are only now beginning to quantify with our particle colliders and detectors. Now let's turn our attention to one of the most enigmatic and celebrated portions of the Rig Veda, the Nasadiya Sukta, often called the Hymn of Creation. This hymn stands out for its breathtakingly modern and almost scientific skepticism, opening with a profound admission of uncertainty about the universe's origin. It describes a state before existence itself, a time when there was neither being nor non-being, neither the realm of air nor the sky beyond. What it does describe is a profound, shimmering potentiality, a void that was not empty but pregnant with possibility. The hymn poetically names this state Tad Ekam, that one thing, an undifferentiated, singular essence that breathed without air, sustained by its own inherent heat. This isn't a description of nothingness, it's a description of a foundational field from which everything could emerge. The language used is particularly striking. The void, or shunya, is not portrayed as a barren emptiness but as a dynamic, darkly luminous ground of existence. The seers speak of a prakitam salalam, a deep, unmanifested watery expanse, a unified field of potential. This directly parallels the modern quantum physical concept of the vacuum state, which is anything but empty. What we call a vacuum is now understood to be a seething, bubbling sea of virtual particles. These are particle-antiparticle pairs that spontaneously flicker into and out of existence, borrowing energy from the vacuum itself for an immeasurably brief moment before annihilating each other and returning that energy. The quantum vacuum is not passive. It is the lowest energy state from which all activity springs, the fundamental background activity of the universe. The Rig Veda's shunya appears to be a poetic but precise metaphor for this very quantum field, a non-empty void that is the source of all something. We find another compelling layer in the concept of ka, a term repeated in the hymns. Ka is an interrogative pronoun meaning who, but in the Vedic context it takes on a much deeper, more enigmatic role. It becomes a name for the primordial unknown, the first cause that even the gods may not understand. The hymns ponder who truly knows, who will here declare it. From whence was it born, from whence this creation? This who, this ka, is presented as the ultimate source, the mysterious catalyst from which the duality of existence sprang forth. This echoes the quantum physicist's question about the origin of the symmetry break that allowed matter to dominate over antimatter. Both the ancient seer and the modern scientist are pointing toward a fundamental, perhaps unknowable, first principle that set the entire cosmic drama into motion. The act of creation in the hymn is described not as a construction from outside materials, but as a manifestation from within this latent field through tapas, which translates as heat, fervor, or intense concentration. This tapas generates the first vibration, the first differentiation, which eventually leads to the pairing of opposites that structure our reality. This is remarkably analogous to the modern theory of cosmic inflation, where a primordial field driven by immense energy underwent a phase transition, expanding exponentially and giving rise to the hot, dense plasma of the Big Bang, a state filled with particle-antiparticle pairs. The Vedic tapas could be seen as a metaphorical description of the immense energy density inherent in the quantum vacuum, the heat that powers the spontaneous creation of virtual pairs and on a cosmic scale may have powered the birth of the universe itself. This interpretation transforms these ancient verses from mere mythology into a sophisticated metaphysical framework. The rishis, through deep meditative insight, may have been attempting to articulate the nature of reality at its most fundamental level. They perceived a universe emerging from a unified field of potential, a void teeming with latent energy that expresses itself through a dynamic dance of complementary pairs. They described this process in the only language they had: poetry, metaphor, and spiritual inquiry. Yet the structural similarities to quantum field theory are too compelling to ignore. They weren't calculating wave functions, but they were mapping the conceptual territory of a reality born from a fertile void. A reality where being and non-being, something and nothing, are inextricably linked in a continuous process of creation and annihilation. This exploration of the quantum void leads us directly to one of the most stunning passages in all of ancient literature, a hymn that seems to peer directly into the heart of creation itself. The Nasadiya Sukta, the creation hymn from the 10th book of the Rig Veda, is breathtaking not for its certainty, but for its profound and honest uncertainty. It begins not with a triumphant declaration from a god, but with a humble admission of the limits of knowledge. It opens by stating that in the beginning there was neither existence nor non-existence, neither the realm of air nor the sky beyond it. There was no death and therefore no immortality, no distinguishing feature of day or night. There was only that one thing, tad ekam, breathing without air, enveloped in a void, sustained by nothing other than its own inherent heat or tapas. The language here is not mythological but deeply metaphysical, almost phenomenological. The seer is describing a state prior to duality, a unified field of potential where the very categories we use to understand the world simply did not apply. This void or shunya is not a barren emptiness. The hymn describes it as a dark, deep, and profound watery expanse, a singular ocean of possibility. This is a remarkable parallel to the quantum vacuum state in modern physics. What we call empty space is anything but empty. It is a seething, bubbling plenum of virtual particle-antiparticle pairs. These pairs constantly flicker into existence, borrowing energy from the vacuum for an infinitesimally brief moment before annihilating each other and vanishing back into the underlying field. The quantum vacuum is the lowest energy state from which all particles and forces emerge, a foundational activity that undergirds everything. The Vedic void appears to be a precise poetic description of this very quantum field, a non-empty void teeming with latent creative energy. The hymn's central concept, tad ekam, that one, is perhaps the most fascinating element. It is not a creator god in a personal sense, but an impersonal, singular essence, the potential for all duality contained within a state of non-duality. This mirrors the concept of a unified quantum field before any symmetry breaking occurred, a state where the laws of physics as we know them did not yet exist, and where matter and anti-matter were perfectly symmetrical and indistinguishable. The breathing without air of tad ekam suggests a self-sustaining dynamic oscillation, a primordial vibration that would eventually manifest as the universe. This is the cosmic equivalent of the first fluctuation in the quantum foam, the initial seed from which the entire cascade of creation would unfold. The catalyst for this unfolding is described as tapas, often translated as heat, fervor, or intense concentration. This is not mere warmth, it is a metaphysical principle of focused energy and intention. It is through this tapas that one first stirred, generating the initial impulse that led to the emergence of order from chaos, of something from the potential of nothing. This is strikingly analogous to the immense energy density theorized to have driven the inflationary epoch of the Big Bang, a burst of exponential expansion that is thought to have been triggered by a phase transition in a primordial field. The Vedic tapas could be seen as the poetic counterpart to this cosmological energy. the heat that powered the universe into being. The hymn's conclusion is its most famously humble and modern feature. After detailing this profound cosmogony, the poet steps back and openly admits the limits of this knowledge. It states that even the highest deity in the highest heaven may not know the origin of creation, for perhaps even they came after it. The final verse wonders, who truly knows, who will here declare it, from whence was it born, from whence this creation? This is not a statement of ignorance, but one of profound intellectual honesty. It acknowledges that the first cause, the reason for the symmetry break that led to our universe, might ultimately be unknowable. This is the exact same wall that modern cosmologists hit. We can describe the process of creation beautifully, but the initial why, the reason our universe has the specific laws and asymmetries it does, remains one of physics' deepest mysteries. The ancient seer and the modern scientist both arrive at the same awe-filled, humble conclusion, standing together in wonder before the ultimate question of existence. This brings us to one of the most profound and elegant dualities in all of Vedic thought, the pairing of Asat and Sat. To grasp the depth of this concept, we need to move beyond their simple translations of non-being and being. This isn't a binary of real versus unreal. It's a sophisticated framework describing two fundamental states of existence, two sides of the same cosmic coin. Sat represents everything that is manifest, tangible, and has name and form. The entire universe of objects, beings, and experiences we can perceive. It is the realm of the defined, the actualized, the world of effects. Asat, in its truest Vedic sense, is not mere nothingness. It is the unmanifest, the field of pure potentiality, the realm of causes. It is the source from which Sat emerges and the ground to which it returns. It is the womb of all possibility. The relationship between them is dynamic and interdependent. You cannot have one without the other. The Rig Veda itself declares Sat was born from Asat, a statement that turns our everyday logic on its head. It suggests that the world of solid matter and distinct forms springs forth from a deeper, more fundamental layer of unformed reality. Think of it like the ocean and a wave. The wave, with its distinct shape, height, and motion, is Sat. It is manifest, defined, and observable. But the ocean itself, the vast, deep body of water from which the wave rises and into which it falls back, is Asat. It is the unmanifest source, holding the potential for an infinite number of waves without being any single one of them. The wave cannot exist without the ocean, and the ocean expresses itself through the wave. Now let's place this ancient insight next to our modern understanding. In particle physics, what we call the quantum vacuum is the closest equivalent to this Vedic concept of Asat. We used to think of a vacuum as completely empty space, a true void, but quantum mechanics revealed this is utterly wrong. The vacuum is a seething, bubbling sea of potential. It is filled with virtual particle-antiparticle pairs that spontaneously blink into and out of existence. These pairs are a perfect expression of the Sat-Asat dynamic. For a fleeting moment, a particle and an antiparticle, a tiny unit of manifest Sat, pop into being from the unmanifest Asat of the vacuum. They exist, and then, in an instant, they annihilate each other, returning their energy back to the quantum field, vanishing back into the unmanifest potential from which they came. The parallels become even more striking when we consider the role of symmetry. In physics, the fundamental laws are believed to be perfectly symmetric between matter and antimatter. This symmetry is pristine and beautiful in the equations, yet it is broken in our observable universe. The Vedic seers also described a primordial, unified state of non-duality, a perfect symmetry, that then differentiated into the dualities we experience, like Sat and Asat, prana and its counterpart. The fact that our universe is made mostly of matter is a massive, unexplained asymmetry. Similarly, the manifest world of Sat seems to dominate our experience, while its source in Asat remains hidden, a background reality we only glimpse through advanced mathematics or deep introspection. Both systems, the ancient and the modern, point toward a perfect, symmetrical foundation that gave way to the asymmetrical world we inhabit. This wasn't just theoretical philosophy for the Vedic seers, it was a truth perceived through direct spiritual experience. They didn't theorize about a sat from a distance. Through intense meditation and inner exploration, they claimed to have accessed this state of pure, unmanifest potential consciousness. They described it as a state of turiya, a fourth state of consciousness beyond waking, dreaming, and deep sleep. In this state, the individual mind quietens enough to perceive the underlying field of reality itself before it differentiates into pairs of opposites. From this vantage point, they weren't observing particles and anti-particles, but they were intuiting the fundamental principle that reality is structured by these complementary pairs emerging from a unified source. Their description of a sat and sat is a metaphysical map of this profound insight, a map that eerily parallels the physical map we are now drawing with our most powerful scientific instruments. It suggests that whether through inward journey or outward experimentation, we are circling the same profound truth about the nature of the cosmos. To truly appreciate the allegorical depth of these ancient stories, we must first step into the symbolic landscape of the Vedas and Puranas. The Devas and Asuras are far more than just characters in a celestial drama. They represent fundamental, opposing principles that underpin the very functioning of the cosmos. The Devas, often translated as the Shining Ones, embody the forces of integration, order, light, and construction. They are the centripetal energy that draws things together, builds structure, and sustains life. Their counterparts, the Asuras, represent the forces of disintegration, chaos, entropy, and dissolution. They are the centrifugal energy that breaks down forms, challenges order, and clears the way for renewal. Critically, neither force is purely good or evil in a moral sense. Both are essential and inevitable aspects of a dynamic, living universe. One cannot exist without the other, and their eternal struggle is the engine of cosmic change. This dynamic finds a stunning parallel in the fundamental interactions of modern particle physics. Imagine a typical subatomic event inside a detector at CERN. A high-energy photon, a packet of pure energy, spontaneously transforms into a particle-antiparticle pair, an electron and a positron. For a breathtakingly brief moment, this pair of opposites exists, born from energy and now possessing mass and charge. They are perfect mirror images, the electron with its negative charge, the positron with its positive. They are the Deva and Asura of this microscopic realm, one representing the stable, familiar matter that builds our world, the other its exotic, annihilating counterpart. Their coexistence is fleeting. Drawn together by their opposite charges, they collide, and in an instant, they obliterate each other in a flash of energy, returning to the formless state from which they came. This is not destruction in a negative sense. It is a transformation, a reset. The energy released is then free to become something new, to fuel the next cycle of creation. Now, let's listen to the ancient myths with this new understanding. The great battle described in the Divi Mahatmyam, where the goddess Durga leads the Devas in a war against the Asura Mahishasura, can be heard as a grand allegory for this process. Mahishasura, the buffalo demon, represents a massive concentration of chaotic, entropic energy, an unstable state of matter that threatens the cosmic order or dharma. The Devas, the forces of order, find they cannot defeat him alone. Their individual weapons are useless. This mirrors how single particles cannot easily counteract a dominant, unstable energy state. The solution is a singular, focused release of energy. All the Devas pool their tejas, their fiery essence, and from that collective energy, the goddess Durga manifests. She is the personification of Shakti, or pure transformative energy itself. She enters the battlefield and after a fierce struggle annihilates Mahishasura. This narrative maps perfectly onto the matter-antimatter annihilation process. The chaotic Asura represents a large quantity of matter. the collective energy of the Devas represents the focused potential for a release of anti-matter. Their merger creates the conditions for a transformative event, the goddess, who symbolizes the annihilating force itself. Her final act of vanquishing the demon is the moment of collision and total conversion, restoring balance by transforming a destabilizing mass back into pure, usable energy. The universe is saved not by destroying the opposing force, but by integrating with it to achieve a higher state of equilibrium. The myth concludes not with mourning for the demon, but with celebration for the restored order, just as a physicist would celebrate the clean energy signature of a perfect annihilation event recorded in their detector. This interpretation elevates these stories from simple mythology to a sophisticated form of knowledge encoding. Without the language of quantum mechanics, the Vedic seers used the rich, resonant language of epic narrative to describe the fundamental laws they perceived operating at all levels of reality. The battles between Devas and Asuras are not primitive explanations for thunderstorms or earthquakes. They are profound allegories for the continuous dance of creation and destruction that occurs in every corner of the universe, from the vastness of galactic collisions down to the frantic, unseen world of the quantum vacuum. They understood that reality is built upon this dynamic tension between opposing forces, and they captured its essence in stories that have endured for millennia, waiting for a time when we would develop the tools to understand the science behind the symbol. While the Vedic hymns offer a philosophical and metaphysical framework, the Puranas give us the blockbuster special effects version of cosmic destruction. These texts describe in vivid, often terrifying detail the events of a pralaya, the dissolution of the entire universe. This isn't a simple ending, it's a systematic, phase-by-phase deconstruction of reality itself, a process that reads less like mythology and more like a precise reversal of the Big Bang, bearing a striking resemblance to a total matter-antimatter annihilation event on the grandest possible scale. The Puranas explain that at the end of the cycle, the destructive aspect of the divine, often personified as Lord Shiva, begins the process of reabsorption. But this isn't a violent explosion outward, it's an implosion, a drawing inwards. The first sign is the drying up of all water sources, followed by a scorching heat from 7 suns that appear in the sky, evaporating all oceans and rivers and burning all life to ashes. The atmosphere itself becomes a blazing furnace, consuming the very air we breathe. This description of an all-consuming, universe-scale fire is the first major parallel. In a matter-antimatter annihilation, the signature outcome is an instantaneous and complete conversion of mass into pure energy, primarily in the form of high-energy gamma-ray photons, the most intense form of light and radiation possible. The Puranic 7 suns could be a powerful metaphor for this unimaginable flash of radiant energy, a light so brilliant and hot that it vaporizes every complex structure it touches, breaking molecules apart and reducing all matter back to its most elemental particulate state. This is the universe being scoured clean by a wave of pure energy, systematically dismantling the work of billions of years of evolution and cosmic construction in a final, fiery crescendo. Once all life and form are incinerated, the process moves to the very fabric of space. The texts describe how the eternal Vishnu, in his form as the divine dreamer, withdraws his breath. This breath is the prana, the fundamental life force and energy that sustains the cosmos. As it is drawn back in, the entire universe begins to collapse. The galaxies, solar systems, and planets lose their cohesion and are pulled inward. The forces that hold atoms together begin to weaken and fail. This mirrors the theoretical endpoint of a complete annihilation scenario, where after all particle-antiparticle pairs have met and converted to energy, the very structures of spacetime itself would begin to unravel. The gravitational and quantum fields that define the dimensions of our reality would lose their stability, causing the cosmos to literally fold in on itself. The final stage of the pralaya is the most profound. All the energy released from the destruction, all the light and heat and motion, is drawn into the body of Mahavishnu. The universe, now a vast, homogeneous ocean of undifferentiated energy, is reabsorbed into its source. The countless individual Brahmandas or universe bubbles float back into the pores of the divine like atoms returning to a greater whole. What remains is a state of potentiality, a latent existence where all the raw materials of creation are present but unmanifest, waiting for the next exhale. This is the ultimate cosmic reset. In scientific terms, this is the universe returning to a state of maximum entropy and symmetry, a singularity of pure energy where all distinctions, including the fundamental difference between matter and anti-matter, cease to exist. It is the ultimate void, but a void pregnant with the potential for a new Big Bang, a new symmetry break, and a new cycle of creation. The Puranic seers, through their grand narratives, may have been describing the inevitable thermodynamic fate of all universes, not a permanent death, but a necessary return to the source to be remade again. While the epic narratives of the Puranas describe the cosmos on its grandest scale, another school of Vedic thought was conducting a meticulous, systematic investigation into the nature of reality at its very smallest. This is the Vaisheshika school founded by the sage Kanada, and its findings are nothing short of astonishing. Centuries before Democritus in Greece, the Vaisheshika philosophers proposed a detailed atomic theory, a vision of a universe constructed from tiny, indivisible particles. But they didn't stop there. Their model included a multi-layered structure of matter that, when examined closely, seems to anticipate not just atoms, but the subatomic realm and the potential for particles and their opposites. The foundational building block of the physical world, according to Kanada, was the paramanu. The word itself is deeply descriptive. Param means ultimate or supreme, and anu means atom. So, a paramanu is the most fundamental, ultimate particle, the final and smallest unit of matter that cannot be divided further. These paramanas were understood to be eternal, indestructible, and beyond sensory perception. They were not all identical. Each had a unique essence or vishesha, based on which of the 5 elemental qualities it expressed: earth, water, fire, air, or ether. A paramanu of earth would be heavy and solid, while one of fire would be light and energetic. This is a remarkable parallel to the modern concept of different elemental particles possessing distinct properties like mass, charge, and spin. Now, a single paramanu by itself could not create the tangible world we experience. For that, Kanada described a process of combination. 2 paramanas would first combine to form a dyad, a primary pair. This dyad was still invisible. 3 of these dyads would then combine to form a triad or an anu, what we would call a molecule. This anu was the smallest visible unit of matter, the point at which a substance could be perceived. This entire process of combination was not random. It was governed by an unseen force, an inherent tendency within the paramanas to unite under specific conditions. This echoes the modern understanding of chemical bonds and the fundamental forces that govern particle interactions. Here is where the theory gets truly fascinating in light of our exploration. The Vaisheshika texts describe these interactions using specific verbs that imply a dynamic and often violent process. They speak of particles striking each other, colliding, and combining with great force. The texts even note that the resulting combinations can sometimes lead to the manifestation of heat and light. Now consider this alongside the process of matter-antimatter annihilation. When an electron meets a positron, they collide with tremendous force, and their combination leads to an instantaneous and total conversion into energy, releasing a precise flash of high-energy photons, which are pure light. The ancient description of invisible particles colliding to produce visible light and heat is a stunningly accurate metaphorical account of this subatomic event. Furthermore, the very structure of their atomic model hints at a necessary duality. If the paramonu is the fundamental, indivisible unit, and the manifest world requires the combination of these units, then logic dictates that for every action of combination, there must be a potential for separation. The texts describe a state of dissolution or pralaya at the cosmic level, where all combinations break down and matter returns to its primordial, undifferentiated state. This cyclical process of building up and breaking down requires a mechanism. Could the concept of an anti-paramonu, a particle whose sole purpose is to dismantle rather than build, be implied within this framework? The annihilating function of an antiparticle is the ultimate expression of this dissolving principle, the precise counterforce needed to break the bonds of matter and return its energy to the source. The Vaisheshika system provides a final, profoundly insightful clue. The sage Kanada stated that the inherent drive for paramanas to combine comes from an unseen causal force, which he called adrishta, meaning the unseen. This is not a passive law, it is an active, intelligent principle that guides the dance of creation. In the context of particle physics, the unseen force that dictates when and how a particle and its antiparticle are created from energy, and how they are drawn together to annihilate, is the complex set of conservation laws and quantum probabilities that govern these interactions. The ancient concept of adrishta, an invisible guiding principle behind the behavior of the smallest particles, resonates deeply with the modern physicist's reality of a universe governed by immutable mathematical laws that operate behind the veil of observable phenomena. It suggests the Vaisheshika philosophers were not just early materialists, but were intuiting a deeply structured and intelligently ordered cosmos, all the way down to its most minute and powerful interactions. This profound understanding of matter at its smallest scale finds a breathtaking parallel in how the Vedic seers conceptualized the very fabric of time and space. Their model of the cosmos presents a universe where time itself is not a single, universal constant, but a fluid and relative experience that changes dramatically depending on where you are and how you are moving. This is most vividly illustrated in the differing time scales assigned to various celestial realms. The ancient texts describe with precise numerical detail that what is just 1 year for the devas, the celestial beings, equates to 360 years here in the human world. This isn't presented as a mystical allegory, but as a factual account of cosmic architecture, suggesting that the higher planetary systems operate within a completely different temporal framework than our own. When we place this ancient concept next to Einstein's theory of special relativity, the parallels are nothing short of astonishing. Einstein's revolutionary insight was that time and space are not absolute. They are woven together into a single fabric called space-time, and this fabric can be warped by gravity and velocity. One of the most famous consequences of this is time dilation, which states that time literally passes more slowly for an object moving close to the speed of light relative to a stationary observer. If you could board a spaceship and travel at an immense fraction of light speed for what felt like just a few years, you could return to Earth to find that centuries had passed for everyone you left behind. Your personal experience of time would have been compressed, just as a single Deva year contains 360 human years. The connection deepens when we consider the environments where such extreme time dilation would naturally occur. According to relativity, the most significant time dilation happens in regions of immense gravity or incredible velocity, conditions that are synonymous with the most energetic and violent events in the universe. Think of the accretion disk swirling around a supermassive black hole where matter is accelerated to near light speed, or the heart of a supernova explosion with its unfathomable energies and densities. It is in these extreme locales where the fabric of space-time is stretched to its limit that the production of matter and antimatter pairs becomes a dominant physical process. The immense energies present are more than sufficient to spontaneously create particle-antiparticle pairs from the quantum vacuum. This creates a fascinating and profound intersection of ancient and modern thought. The Vedic texts identify the higher realms, the abodes of the Devas, as places of immense light, energy, and stability, realms that sound less like mythological heavens and more like descriptions of environments with extreme energy densities. If we interpret these realms not as mythological places but as allegorical descriptions of high-energy cosmological phenomena, a startling possibility emerges. The Vedic seers, through their deep introspection, may have been intuiting a fundamental cosmic principle, that regions of immense energy and altered time are also the very cradles of creation for both matter and its shadow counterpart. The Deva years could then be understood as a metaphorical way of expressing the time dilation effects that will be experienced by or observed from within such an energetic environment. A process that takes 1 year from the perspective of that high energy state, like the creation and interaction of particle pairs, could indeed correspond to a vast passage of time in the slower moving, lower energy reality of our human world. Their descriptions of these realms as being composed of purer, brighter elements could be a poetic rendering of a plasma state, the fourth state of matter dominated by light and energy, which is exactly the environment where antimatter is most readily produced and studied today. This suggests that the Vedic model of tiered realities with fluid time is not a primitive fantasy but a sophisticated conceptual mapping of universal laws. They seem to grasp that the nature of reality changes depending on its energy context, and that time itself is a variable in that equation. By linking dilated time with the domains of luminous beings, they may have been symbolically pointing toward the precise physical conditions where the fundamental symmetry between matter and antimatter is most actively played out. It is a breathtaking inference that the keys to understanding the universe's most exotic substances might be hidden within ancient descriptions of time itself, waiting for a civilization to develop the scientific language to decode them. Perhaps the most compelling layer of this mystery lies not in the grand narratives or philosophical concepts, but in the precise, almost mathematical language of the Vedic mantras themselves. These are not simple prayers or poems, they are intricate vibrational formulas composed with a level of phonetic and syllabic precision that has fascinated scholars for centuries. The seers placed immense importance on the exact pronunciation, rhythm, and repetition of these sounds, believing their correct utterance could literally alter reality. This suggests they understood something profound about the power of specific frequencies and numerical patterns. When we look at these patterns through a modern lens, we start to see potential correlations that are difficult to dismiss as mere coincidence. Let's consider the concept of Sankhya, which means number. The Vedas are saturated with significant numbers that appear again and again. The most famous is the sacred syllable Om, which is said to encompass all of reality. In the Sanskrit alphabet, Om is considered the primordial vibration, the root sound from which all other sounds emerge, but its significance is also numerical. The syllable is often analyzed as consisting of 3 phonemes, A, U, and M, representing the states of waking, dreaming, and deep sleep, which together transcend into a 4th state, Turiya, or pure consciousness. This structure of 3 plus 1 is a fundamental numerical pattern seen throughout creation, from the 3 spatial dimensions plus time to the 3 quarks that make up a proton. Now let's go deeper into a specific example, the Gayatri Mantra, one of the most revered hymns in the entire Vedic tradition. It is composed of 24 syllables arranged in a specific meter. This isn't an arbitrary number. 24 is a highly composite number, meaning it has many divisors, making it incredibly useful for organizing cycles. We have 24 hours in a day, and in ancient India, the day was divided into 24 periods. But could this number also point to something more fundamental? Some researchers have drawn a potential parallel to the number of fundamental particles in the standard model of physics. In the standard model, there are 12 matter particles, 6 quarks and 6 leptons, and 12 force-carrying particles, including the photon, the gluons, and the W and Z bosons. That's a total of 24. While the correspondence isn't perfect and the standard model is still evolving, the numerical symmetry is intriguing. The ritualistic use of numbers is even more precise. The Yajurveda details fire sacrifices, or yajnas, where offerings are made into a consecrated fire with the chanting of specific mantras. The number of repetitions, the count of offerings, and the arrangement of altars are all dictated by exact numerical values. For instance, the construction of the fire altar involved laying down bricks in 5 layers, representing the 5 elements with a total of 196 bricks. This number, 196, has been noted by some to have a curious relationship with atomic physics. The most common isotope of gold, a metal highly symbolic of purity and immortality in many traditions, has an atomic mass of 197, which is remarkably close. Could the altar's construction be a symbolic representation of building or transmuting matter at an atomic level? The most tantalizing possibility is that these numerical codes might contain information about the universe's initial conditions. The greatest puzzle in cosmology is the Baryon asymmetry problem. Why there was just a tiny bit more matter than antimatter in the early universe, allowing our cosmos to exist. The ratio is estimated to be around 1 part in a billion. That is, for every billion particles of antimatter, there were 1,000,000,001 particles of matter. After the mutual annihilation, that 1 part in a billion is all that remained to form everything we see. Is there a numerical value in the Vedas that points to this ratio? We find a potential clue in the concept of time. The yugas, the great cosmic cycles, have durations based on multiples of 432,000. The Kali Yuga lasts 432,000 years, the Dvapara Yuga twice that, and so on. The number 432 appears throughout ancient cultures, from the number of syllables in the Rig Veda to the Assyrian sacred number. But 432,000 is also very close to the square of 656, which is 430,336. Why is this significant? Some speculative theories in physics have attempted to link the matter-antimatter asymmetry ratio to fundamental constants, and the numbers involved are on this immense scale. While a direct one-to-one link is a tremendous leap, the persistent appearance of such large, non-random numbers in a cosmological context is what makes this line of inquiry so fascinating. It suggests the seers were thinking in terms of the vast numerical constants that govern the universe's behavior. This isn't to say the Vedic rishis were writing a textbook on quantum mechanics. They were encoding profound cosmological truths in a language of symbolism, meter, and number, a language designed to be meditated upon and realized through direct experience, not just intellectually understood. The repetition of a mantra 108 times, a sacred number representing the union of the 3 realms of existence and the 36 elemental principles, wasn't just a ritual, it was a technology of consciousness. By aligning their own vibration with these fundamental numerical patterns, they sought to directly perceive the architecture of reality. Whether these numbers correspond exactly to the mass of an electron or the precise matter-antimatter ratio is almost beside the point. The deeper insight is their recognition that the universe is built upon a foundation of mathematical relationships, and that by understanding these relationships, one can understand the very heart of creation. To truly appreciate the potential parallels, we need to reimagine these ancient ceremonies not as superstition, but as sophisticated physical and metaphysical operations. At its core, a Vedic yajna is a meticulously orchestrated process of transformation. Specific materials, clarified butter, grains, medicinal herbs, and sacred woods, are offered into a consecrated fire by priests who chant precise mantras. The tangible offering, the havis, is consumed by the flames and visibly changes state. solid and liquid matter becomes heat, light, and smoke rising into the atmosphere. This is a literal, observable conversion of matter into energy and other forms of matter, a principle that sits at the very heart of modern physics. The ritual can be seen as a symbolic enactment of Einstein's famous equation, where mass is not destroyed but transformed, its energy released and redistributed into the cosmos. The symbolism deepens when we consider the intended outcome of these rituals. The offerings weren't merely destroyed, they were believed to be transmuted into a subtler, more potent form to nourish the devas, the celestial beings who maintain cosmic order. In a sense, the yajna was envisioned as a cosmic refueling station, converting gross physical substance into a refined energy that could sustain the machinery of the universe. This bears a striking conceptual resemblance to the matter-antimatter annihilation process, where two tangible particles are not just broken apart, but are completely converted into pure, usable energy gamma radiation, the most potent and refined form of energy known to physics. In both models, a violent, high-energy event is the necessary mechanism for this ultimate transformation, releasing power that fuels a larger system. The design of the ritual fire altar itself, the Vedi, adds another layer of intrigue. It was constructed with precise geometric proportions, often resembling a bird with outstretched wings. This shape is highly aerodynamic, designed to create a strong upward draft, ensuring the smoke and offerings would rise efficiently toward the heavens. This focus on channeling the products of the fire skyward mirrors the directional nature of energy release in a controlled annihilation event. In a particle detector, the energy from an electron-positron annihilation is emitted as two gamma-ray photons flying away from each other in opposite directions, a clean and focused release of power. The altar's design seems to intuitively understand the need to direct this transformative energy toward a specific purpose and destination. The mantras chanted during the offering are the final, crucial component. Each syllable was considered a vibrational code, a set of specific sound frequencies designed to resonate with the fundamental fabric of reality. The seers believed that correct pronunciation would align the ritual with the cosmic laws it sought to influence. From a modern perspective, we can see this as an attempt to couple the physical process of combustion with an informational or vibrational key. In particle physics, the outcome of high-energy collisions is governed by immutable mathematical laws and conservation rules, a kind of cosmic code that dictates what can and cannot be created. The mantras might be seen as a symbolic representation of this underlying code, the vibrational command that instructs the energy on how to properly transform and where to go. This reinterpretation invites us to view the ancient rishis not as primitive worshippers, but as early scientists and engineers of consciousness and energy. They may not have had the mathematical language of quantum field theory, but through deep introspection and observation, they developed a practical, ritualistic technology to model what they perceived as the fundamental processes of the cosmos. The yajna is a macro-scale, ritualized metaphor for the micro-scale events that power the stars and shape the universe. They understood that reality is a constant dance of transformation, of things being consumed to release the energy that builds anew. Their fire altar was their particle accelerator, their offerings were their test particles, and their mantras were their equations, all working in concert to demonstrate a profound truth about the energetic nature of existence. This principle of opposites extends far beyond simple physical sensations into the very framework of Vedic metaphysics, where it is known as Dvandva. The term Dvandva doesn't just mean a pair. It signifies a dynamic, interdependent duality, a pair of opposites locked in an eternal dance that generates the tension necessary for all experience and manifestation. Think of it as the cosmic engine that runs on contrast. We experience pleasure because we understand pain, we know light because we have shadow, and we comprehend sound against a backdrop of silence. These are not merely philosophical ideas. the ancient seers presented them as fundamental laws of nature, the very pillars upon which the illusory world of names and forms is constructed. This system of paired opposites is mapped with intricate detail throughout the texts. It begins with the most immediate experiences: heat and cold, hunger and thirst, honor and dishonor. But it quickly expands to encompass the entire human condition, governing our emotional and mental states: joy and sorrow, love and hatred, courage and fear. This isn't a random list, it's a comprehensive catalogue of the polarities that define conscious existence. The profound insight of the rishis was that freedom, or moksha, was not found by pursuing one pole and rejecting the other, but by achieving a state of equanimity that transcends the dvandvas altogether. The enlightened being is described as one who remains steady, undisturbed by the constant push and pull of these opposing forces. This conceptual framework of necessary opposites provides a powerful lens through which to view the modern discovery of antimatter. If the Vedic world view is correct in its assertion that all of manifest reality is built upon these fundamental dualities, then why would the building blocks of matter itself be an exception? The seers observed duality at every level of creation, from the vast cycles of the cosmos down to the fluctuations of the human mind. It is a perfectly logical extension of this principle to propose that at the most fundamental, particulate level of physical reality, this same law of duality would express itself. For every particle that possesses the properties we associate with stable matter, there must exist its opposite, its shadow twin, its dvandva partner, whose very nature is to counterbalance and ultimately negate its counterpart. This perspective transforms antimatter from a bizarre 20th century anomaly into an inevitable and necessary feature of a universe built on dichotomies. The electron, with its negative charge, finds its dvandva partner in the positron with its positive charge. The proton's positive charge is balanced by the antiproton's negative. This isn't a flaw in the design of the universe, it is the design. The mutual annihilation that occurs when matter meets antimatter is simply the most dramatic and ultimate expression of this principle of opposition. It is the final reconciliation of a duality, the moment where the two opposing forces cancel each other out and return to the undifferentiated, unified source from which they emerged, a process the Vedas would describe as a return to Brahman. The brilliance of this ancient system is that it doesn't isolate this physical duality from all others. It sees it as part of a cohesive, interconnected whole. The same fundamental law that governs the pairing of light and dark, or life and death, also governs the relationship between particle and antiparticle. This suggests that the Vedic seers, through their deep exploration of consciousness and the macrocosm, intuitively arrived at a truth about the microcosm. They may not have known the technical details of quantum spin or charge parity, but they understood the overarching architectural principle that the universe requires these opposing pairs to function. The existence of antimatter, therefore, is not a surprise from this viewpoint. It is a confirmation of a timeless, universal law of duality that permeates every layer of existence, from the spiritual to the subatomic. Within this intricate dance of opposites, the concept of tejas emerges as a radiant and vital force, the brilliant energy that is both a product and a purifier of cosmic interactions. In the Vedic framework, tejas is far more than simple fire or light. It is the essence of luminosity, the principle of spiritual and physical splendor, and the power of transformative energy. It is the radiant aura of an enlightened being, the fierce heat of a warrior's courage, and the brilliant light of a star. This energy is described as having the power to burn away ignorance and impurity, to illuminate truth, and to act as a conduit for higher consciousness. Its nature is both creative and destructive, capable of sustaining life or reducing forms to their essential essence. The generation of tejas is intimately tied to the dynamic interplay of opposing principles. The texts describe how this radiant energy is often produced through tapas, a word meaning heat or fervor generated by intense discipline, concentration, or the friction of conflicting forces. This is not a passive process. It is an active, often challenging, transformation where latent potential is converted into manifest power. The clash between devas and asuras, for instance, is frequently said to generate immense tejas, a brilliant light that can then be harnessed by the victorious side. This mirrors the physical process where the meeting of matter and antimatter, two perfect opposites, results not in mere darkness but in an explosive release of the purest form of energy known to physics, high-energy gamma radiation. The parallel between the ancient concept and the modern scientific observation is remarkably precise. Gamma rays are photons, packets of pure electromagnetic energy, born from the most violent and energetic events in the universe. They are the universe's ultimate reset button, possessing enough energy to break apart atomic nuclei. In a matter-antimatter annihilation, the entire mass of the two particles is converted directly into gamma-ray photons in accordance with Einstein's equation. This is the physical counterpart to the Vedic idea of tejas, a brilliant, purifying, and fundamental energy that results from the ultimate reconciliation of duality. The annihilation isn't a negation, it's a transformation into a purer state of energy. The Vedic seers assigned this radiant energy a crucial role in the cosmic order. Tejas was understood to be the sustaining force of the sun and the stars, the very source of light that makes life possible. It was also seen as the energy that fuels consciousness and spiritual awakening within an individual. This dual role, powering both the external cosmos and the internal world of the mind, suggests a deep intuition about the unified nature of energy itself. They recognize that the same fundamental principle that causes a star to shine also allows a seeker to attain enlightenment. The brilliance of a galaxy and the insight of a sage were seen as different manifestations of the same essential force, tejas. This holistic view implies that the ancient rishis may have intuitively understood a profound truth that science continues to explore, that all forms of energy are interconnected and transformative. The gamma radiation from a particle annihilation and the perceived aura of a spiritual master could be interpreted as different points on a vast spectrum of energy manifestation. By describing tejas as the product of opposing forces finding resolution, the Vedas provide a metaphysical model that astonishingly prefigures one of the most energetic processes in particle physics. They saw the universe not as a static collection of objects, but as a dynamic play of energies, constantly being consumed and reborn through the radiant power of tejas, a light born from the final embrace of opposites. Yet the astronomical observations within the Vedas extend far beyond simple star charts or lunar cycles. They reveal a level of precision that seems to defy the technological capabilities of an ancient civilization. The texts describe the slow, wobbling precession of the equinoxes, a cycle that takes 25,920 years to complete. They calculated the relative orbital periods of the planets with stunning accuracy. For instance, their value for the solar year was 365.258,756 days, a figure that is remarkably close to our modern calculation of 365.25636 days. This isn't a rough estimate, it's the product of meticulous long-term observation and a highly sophisticated mathematical tradition. How could they achieve such precision without telescopes or complex instruments? The answer might lie in a different kind of science, one that combined celestial observation with a deep, internal exploration of consciousness itself. One of the most compelling celestial descriptions is found in the accounts of the star system Sirius or Svati. The Vedic texts describe it as a tri-temporal star, a concept that baffled scholars for centuries. They noted it had a faint, hidden companion, a description that aligns perfectly with the discovery of Sirius B, a white dwarf star that is incredibly dense and difficult to observe even with modern telescopes. This companion star wasn't confirmed by Western astronomy until the 19th century. How could the Vedic seers have known about it? This suggests their methods of perception, perhaps honed through advanced meditative states, allowed them to access information about the cosmos that should have been technologically impossible for their time. They weren't just looking at the sky, they were perceiving the underlying energetic architecture of the stars. The descriptions of planetary motions go far beyond simple observation. They hint at an understanding of gravitational influences and orbital mechanics. The texts speak of the forces that hold the celestial bodies in their paths, attributing this to a fundamental cosmic order they called Rita. This concept of an invisible, governing force that maintains the harmony of the spheres is a profound precursor to Newton's law of universal gravitation. They understood that the same laws applied to the movement of the planets as to the falling of an apple on Earth, a radical idea of universal physical laws that wouldn't emerge in the West for millennia. This holistic view of physics, where the macrocosm of the galaxy and the microcosm of the atom are governed by the same principles, is a cornerstone of both Vedic thought and modern theoretical physics. This brings us to the critical question: if their astronomical knowledge was so advanced, what was their model for the cosmic engine? How did they believe these celestial processes were powered? The texts frequently refer to the immense energy and light of the stars, describing them as powered by a form of internal toppers or fervor. This is where a potential connection to concepts like antimatter emerges. Modern astrophysics has discovered that some of the most energetic events in the universe, such as gamma-ray bursts and the relativistic jets spewing from active galactic nuclei, are likely powered by matter-antimatter annihilation processes. These are the universe's most powerful engines, converting mass to energy with 100% efficiency. The Vedic descriptions of cosmic creation and destruction cycles, the pralaya, vividly depict stars flaring up with immense brilliance and novas exploding. Could their concept of a star's internal toppers be a metaphorical understanding of these incredibly high energy reactions? When they describe the sun as sustained by a form of internal sacrifice, a constant process of consumption and release, it echoes the continuous fusion reactions in a star's core. But for even more violent events, the metaphor of annihilation fits even more precisely. The brilliant flash of light from a matter-antimatter meeting is the purest expression of tejas, the radiant energy they described as the fundamental substance of light. Their astronomical data, combined with their metaphysical framework, paints a picture of a universe alive with transformative energy, a concept we are only now beginning to quantify with our satellites and particle detectors. Their science wasn't separate from their spirituality. It was a unified vision of a conscious, energetic cosmos, and their celestial observations were a key part of mapping its magnificent and violent workings. This brings us to one of the most profound and far-reaching concepts in all of Vedic philosophy, the principle of Maya. Often translated simply as illusion, this word carries a weight and sophistication that is frequently lost. Maya is not the idea that the world is an unreal hallucination. Rather, it is the divine creative power that projects the tangible universe from the unmanifest source, all while veiling its true, unified nature. It is the cosmic magic trick that makes the one appear as the many, convincing us that the temporary, ever-changing names and forms are the ultimate reality. The world is real, but its reality is conditional and relative, like the reality of a character in a dream. Maya is the force that creates this magnificent, convincing dream of separation. This ancient concept finds a startlingly resonant echo in one of the most bizarre and confirmed phenomena of quantum physics, vacuum fluctuations. What we once thought of as empty space is now understood to be a seething, dynamic plenum. At the smallest scales, for immeasurably brief moments, the void itself gives birth to pairs of virtual particles, a particle and its antiparticle twin. They spontaneously flicker into existence, borrowing energy from the vacuum, only to meet and annihilate each other a fraction of a second later, returning the energy and vanishing without a trace. This isn't a theoretical idea, it's a measured reality with observable effects. The very fabric of space-time is not static, it is alive with this perpetual, fleeting dance of creation and destruction. When we place these two ideas side by side, the parallels are breathtaking. The virtual particle pair is a perfect microcosmic expression of Maya. It is something that appears real, that follows the laws of physics, that exerts a measurable force, and yet has no permanent, independent existence. It is a transient phenomenon that emerges from and submerges back into the underlying field. This is precisely how the Vedantic seers described the entire manifest universe, as a temporary, dynamic expression that depends entirely on the sustaining power of the foundational reality, Brahman. The virtual pair exists, but its existence is fleeting and dependent, a tiny ripple in the field. In the same way, the mountain, the ocean, and our own bodies are real in their experience, but their independent, permanent reality is the illusion crafted by Maya. The role of the observer in both frameworks deepens this connection. In quantum mechanics, the act of observation is famously linked to the collapse of the wave function, determining a particle's definite state from a cloud of probabilities. The universe seems to require a conscious interaction to actualize its potential. Vedanta takes this a step further, proposing that the entire projected universe of Maya requires a fundamental consciousness, the witness or sakshi, to give it any apparent reality at all. Without this conscious ground, the projection would be like a movie playing in an empty theater, a phenomenon with no one to perceive it. The fleeting virtual particles flicker in the void, and the world of form unfolds in time and space, both requiring the light of awareness to be known, to even be said to be. This isn't merely an interesting coincidence. It suggests that the ancient philosophers, through deep introspection, arrived at a metaphorical understanding of reality's quantum nature. They perceived that the solid, stable world we experience is, at its core, a constant, dynamic process of momentary creation and dissolution. The dance of the virtual particle-antiparticle pairs is the scientific, measurable correlate to the philosophical concept that all form is transient and dependent. Maya is the grand principle, vacuum fluctuations are its minute mechanistic expression. Both point toward a universe that is fundamentally energetic, vibrational, and fleeting, a magnificent and convincing appearance projected upon a more profound, unified, and silent ground of being. This intricate architecture of the cosmos is mapped in stunning detail through the Vedic concept of lokas, a system of multiple dimensions or planes of existence that coexist and interpenetrate our own physical reality. Far from being a simple heaven and hell dichotomy, the lokas represent a sophisticated cosmology of graduated frequencies, each realm vibrating at a specific level of density and consciousness. The texts describe 14 primary lokas arranged in a hierarchical structure, with our earthly dimension, Bhuloka, situated right in the middle. But this structure isn't merely vertical, it's a complex model of parallel realities, each governed by its own distinct laws of physics, time, and matter. The seers described these realms not as distant places one travels to after death, but as dimensions that are present here and now, yet imperceptible to our ordinary senses because they operate on a different vibrational frequency. The descriptions of these realms often emphasize their mirrored or complementary nature. Directly above our Bhuloka is Bhuvarloka, a subtle atmospheric realm, and above that is Svargaloka, a dimension of light and celestial beings. But for every loka described, there is often a corresponding realm below. Just beneath the earthly plane lies Atala, a realm of heightened sensory experience and material fascination. Below that is Vaitala, a domain of shadowy forms and lost treasures, and further down still are Sutala, Talatala, Mahatala, Rasatala, and finally Patala, often described as a world of immense power and potential, but also of profound darkness and dissolution. This isn't a literal description of a subterranean world. It's a metaphorical mapping of states of consciousness and their corresponding energetic environments. The lower lokas are frequently portrayed as inverted or mirrored reflections of the higher ones, realms where the fundamental principles that govern reality appear twisted or expressed through a different lens. It is within this framework of mirrored, parallel dimensions that we can begin to explore a truly fascinating possibility. Could the descriptions of these opposite realms, particularly the contrast between the luminous, energy-sustained higher lokas and the dense, matter-dominated lower lokas, be a metaphorical representation of the matter and antimatter domains predicted by modern physics? Cosmological theories, such as those proposed by physicists like Andrei Sakharov, have long entertained the idea that the matter-antimatter asymmetry we observe in our universe might not be universal. It is theoretically possible that beyond the horizon of our observable cosmos, or even in a different vibrational state, there could exist domains where antimatter predominates. These would be true mirror universes where the electrical charges and quantum numbers of all particles are reversed. The Vedic descriptions of the lower lokas bear a remarkable, albeit allegorical, resemblance to what such an anti-world might be like. The Puranas describe Patala as a place of immense riches and power, but also of a fundamentally different order. Its inhabitants, the Nagas, are often depicted as possessing great wisdom but also a dangerous, volatile nature. The environment is described as opulent yet unstable, a realm where conventional rules don't apply. If we interpret this not as a moral judgment but as a cosmological one, it sounds eerily similar to a domain built on inverted physical laws. A matter-based being entering an antimatter realm would indeed find it a place of immense energy and potential, as any interaction would result in a catastrophic release of power, but also incredibly perilous and unstable. The riches of Patala could be a metaphor for the incredible energy density locked within antimatter, while its danger reflects the annihilating consequence of contact between the two substance domains. The connection deepens when we consider the barriers between these realms. The texts state that moving between lokas is not a physical journey but a shift in consciousness or vibrational state. A being must refine or alter its own energetic signature to perceive and interact with a higher or lower dimension. This is profoundly analogous to the theoretical barrier that would separate a matter universe from an antimatter universe. The boundary wouldn't be a physical wall in space. It would likely be a region of intense energy, a domain of continuous annihilation where the two substance realms meet, preventing them from freely mixing. To cross such a boundary, matter would have to be completely transformed into energy first, a process that aligns with the Vedic idea of achieving a purified, energetic state to transcend one's plane of existence. This interpretation suggests the rishis were not just myth-makers but profound cosmologists who developed a multi-language to describe the architecture of reality. They used the rich, symbolic language of lokas to articulate a universe of incredible complexity, one built on a foundation of complementary and opposing domains. Their descriptions of mirrored worlds, vibrational barriers, and realms of inverted properties may be the ancient world's most sophisticated attempt to model a cosmic principle we are only now beginning to grasp, that for our world of stable matter to exist, there must logically be its counterbalancing opposite, a shadow realm of potentiality whose very nature is to annihilate and transform. Hidden from our perception by the very laws of physics that define our existence, this concept of the universe as vibration finds its most beautiful and profound expression in the Vedic idea of Nada Brahma, the world is sound. This is not a metaphor for music in the conventional sense. It is a radical declaration that the fundamental substance of reality is Shabda, or sacred sonic vibration. The ancient seers described a cosmic, primordial hum from which all of existence emanates, a root frequency that differentiates into the infinite array of forms we perceive. The entire manifest cosmos, from the spiral of a galaxy to the structure of an atom, is seen not as inert matter, but as a complex symphony of interconnected vibrations, each with its own unique frequency and quality. This sound is not something the universe makes, it is what the universe is made of. The most famous single embodiment of this principle is the syllable Om, considered the seed mantra of all creation. The Mandukya Upanishad is entirely devoted to unpacking its profound meaning. Om is described as encompassing all of time, past, present, and future, and all states of consciousness. Its three phonetic components, A, U, and M, represent the waking state, the dreaming state, and the state of deep sleep. And the silent pause that follows is the fourth state, Turiya, pure consciousness itself. Chanting Om is not a prayer to a distant god. It is an act of tuning one's own individual vibration to resonate with the fundamental frequency of the cosmos, a practical technology for aligning with the source code of reality. When we place this ancient concept next to the frontiers of modern theoretical physics, the parallels are not just intriguing, they are staggering. String theory, one of the leading candidates for a theory of everything, proposes that at the most fundamental level, the universe is not composed of point-like particles. Instead, the building blocks of reality are unimaginably tiny, one-dimensional vibrating strings. What we perceive as an electron is not a tiny ball, it is one specific vibrational pattern of a string. A quark is a different pattern, a photon another. The unique resonance of each string dictates the mass, charge, and spin of the particle it manifests as. In this model, the entire universe is a cosmic symphony played on these infinitesimal strings, a direct and breathtaking echo of the Vedic Nada Brahma. This vibrational model provides an elegant potential mechanism for how particle-antiparticle pairs could spontaneously arise. In the quantum vacuum, energy is never truly zero. It is a seething sea of potential. According to this framework, the fluctuating energy of the vacuum could cause a string to vibrate in a specific pattern, manifesting as a particle, but vibrations often occur in harmonic pairs. It is entirely plausible within this model that the vacuum fluctuation would simultaneously excite the string to also vibrate in its exact opposite mirror image pattern, creating its antiparticle counterpart. The dance of creation and annihilation we observe would simply be the coming together and cancelling out of these complementary vibrational modes, a fundamental dissonance and resolution in the music of the strings. This idea finds further support in quantum field theory, which describes particles not as solitary objects but as localized excitations, or quanta, in an underlying invisible field that fills all of space. The electron field, the quark field, the photon field, these are the true fundamentals. An electron is simply a place where the electron field is vibrating in a particular way. The void of space is not empty, it is alive with the potential vibration of all these fields. A particle-antiparticle pair flashing into existence is a momentary, coordinated excitation of a field and its conjugate counterpart, a ripple that appears and then smooths itself out. The Vedic concept of Nada Brahma and the quantum field theorists' view of a universe of vibrating fields are conceptually remarkably similar visions of reality. Both see the solid world as an illusion, a temporary pattern of energy emerging from a more fundamental, vibrational substrate. The practical application of this knowledge in the Vedic tradition was the science of mantra. A mantra is not a simple phrase, it is a precisely formulated sequence of sonic vibrations designed to produce a specific effect in consciousness and, by extension, in the material world. The rishis meticulously mapped the effects of different sounds on the human system, encoding this knowledge into powerful mantras like the Gayatri. The belief was that by correctly intoning these vibrational formulas, one could literally restructure reality at a subtle level. This can be seen as an ancient, intuitive parallel to the modern understanding of wave function collapse in quantum mechanics, where the act of observation, a form of interaction, determines a specific outcome from a field of probabilities. The mantra is the conscious intention expressed as vibration that influences the vibrational field of reality itself. The brilliance of the Vedic seers was their holistic approach. They didn't separate the science of outer vibration from the science of inner consciousness. They understood that the ultimate instrument for perceiving Nada Brahma was not an external device, but a refined and focused human awareness. Through deep meditation, they claim to directly perceive the vibrational nature of reality, hearing the anahata nada, the unstruck sound, the silent hum of the universe that is the source of all manifest sound. This inner experience provided them with a direct empirical data point that we are only now beginning to approximate with billion-dollar particle colliders. Their conclusion was that consciousness and vibration are inextricably linked, that the music of the strings is ultimately a music of the mind, a cosmic symphony composed by a divine intelligence and experienced by every one of us as the wondrous, solid, and beautifully illusory world we call home. To unlock the deeper layers of Vedic knowledge, we must learn to read its visual language, a sophisticated system of symbols that function less as simple icons and more as condensed diagrams of cosmic law. These are not passive images to be merely looked at. They are dynamic geometric gateways designed to be meditated upon, tools for focusing the mind on the fundamental principles that structure reality itself. Perhaps the most misunderstood of these symbols is the swastika. For centuries across Asia, long before its tragic appropriation in the 20th century, this was a sacred emblem of auspiciousness and well-being. Its name itself comes from the Sanskrit su meaning good and asti meaning to be, but its power lies in its geometry. The swastika is not a static cross, it is a rotating wheel, a hooked cross with arms bent at 90 degrees, suggesting constant dynamic motion. This symbolism of rotation is the first key. The swastika represents the cyclical nature of the cosmos, the perpetual turning of the ages, the yugas, the endless cycles of creation, preservation, and dissolution. It depicts a state of balanced spinning energy, a vortex. Now consider the dynamics of particle physics. When a particle and its antiparticle, like an electron and a positron, are created from energy, they are often formed with something called spin. This isn't literal spinning like a top, but an intrinsic form of angular momentum, a fundamental property all particles possess. These spins can be aligned or opposed. The swastika, with its arms spinning in a defined direction, can be seen as a symbolic representation of this intrinsic spin state, a geometric metaphor for the fundamental rotational energy inherent in all matter. Furthermore, the fact that the swastika can be oriented to spin clockwise or counterclockwise mirrors the perfect symmetry and potential asymmetry between particles and their mirror image antiparticles. It is an ancient geometric nod to the chiral nature of the universe, the idea that the direction of spin is a fundamental differentiator in the subatomic world. Next, we turn to the king of all Vedic symbols, the primordial syllable Am. We've touched on its sonic nature, but its visual representation, often called the Amkar, is a geometric marvel in its own right. When written in Sanskrit, it is not merely a letter but a complex, curving symbol comprised of several distinct elements. It is said to be formed from several curves, a crescent moon, and a dot. Each component holds profound meaning. The large lower curve represents the waking state of consciousness. The upper curve signifies the state of deep sleep. The middle curve that extends outward from the center represents the dreaming state. The crescent shape above the curve symbolizes illusion or maya, the veil that separates the individual from the ultimate reality. And the dot at the very top represents the transcendental state, turiya, pure, absolute consciousness. This layered structure offers a potential symbolic blueprint for the layered nature of reality. The three curves could be seen as representing the three fundamental states of matter, solid, liquid, and gas, or even the three gunas, the qualities of nature. The crescent of Maya perfectly represents the quantum field, the realm of potentiality and virtual particles that flicker in and out of existence, the veil that makes the underlying oneness appear as many. The dot, the ultimate point, is the singular, unified source from which all duality emerges, the Brahman, which in a physical sense could be analogous to the singular, high-energy state of the universe before the symmetry break that created matter and antimatter. The entire symbol, therefore, is not just a sound but a complete cosmological map, charting the journey from undifferentiated oneness through the veiled illusion of duality and back to the source. It encodes the entire process of manifestation and dissolution, the very cycle that matter and antimatter partake in every time they annihilate and return to energy. The most mathematically precise and potent of these symbolic tools are the yantras. A yantra is literally a machine or an instrument, a complex geometric composition of interlocking shapes, primarily triangles, circles, squares, and lotus petals, arranged in a precise, symmetrical pattern around a central point or bindu. The most famous of these is the Sri Yantra, a breathtakingly intricate configuration of 9 interlocking triangles, 4 pointing upward and 5 pointing downward, surrounded by 2 concentric circles of lotus petals and enclosed within a square gateway with 4 openings. The upward pointing triangles represent the masculine, active principle, Shiva, often associated with pure consciousness. The downward pointing triangles represent the feminine, receptive energy, Shakti, often associated with creative power and matter. Their perfect interpenetration symbolizes the inseparable union of consciousness and energy, spirit and matter, from which all creation springs. This geometric interplay is a direct and stunning allegory for particle physics. The central bindu, the dimensionless point, is the singularity, the source of infinite potential. The first triangle that emerges from it represents the first emergence of duality from unity. As the triangles multiply and interlock, they create a web of increasing complexity, symbolizing the cascading creation of the diverse universe from a single source. Now consider the interactions of particles. The meeting of a particle and antiparticle is the ultimate interaction of opposites, resulting in a flash of energy that returns to the source. In the Sri Yantra, the points where the Shiva and Shakti triangles intersect are called marmas, and they are points of immense energetic power. These intersections can be seen as symbolic representations of those annihilating collisions, the points where opposing principles meet and release their energy back into the geometric fabric of the yantra, which represents the cosmos itself. The entire yantra is a stable, balanced system, yet it is dynamically generated by the tension between opposing forces. It is a frozen image of the continuous dance of creation and destruction, a geometric equation for the balanced asymmetry that allows a universe to exist. The precision of these symbols suggests they are far more than spiritual art. They are sophisticated instruments of consciousness, designed to align the mind with the architectural blueprints of reality. By meditating on the Sri Yantra with its perfect symmetry and proportional relationships, a practitioner is essentially tuning their awareness to the fundamental frequencies and geometric laws that govern the cosmos, from the structure of a crystal to the orbit of a planet to the interaction of fundamental particles. The swastika encodes dynamic spin. The Omkar maps states of consciousness and reality. The Sri Yantra diagrams the cosmic dance of opposing forces. Together, they form a symbolic language that conveys, through shape and proportion, the deepest secrets of a universe built on symmetry, vibration, and the eternal, annihilating embrace of opposites. The journey from ancient text to modern laboratory is a fascinating one, and it's within the hallowed halls of India's own premier technological institutes that this bridge is being built with increasing rigor. The Indian Institutes of Technology, or IITs, have become surprising hubs for this interdisciplinary exploration, where professors of physics and computer science are collaborating with Sanskrit scholars to analyze these ancient works with a fresh scientific lens. This isn't about proving the Vedas are a science textbook. It's a more nuanced inquiry into whether these profound philosophical systems can offer conceptual frameworks or even predictive models that resonate with our current understanding of the physical world. The approach is methodological, often involving the digitization of vast Sanskrit corpora and the application of complex algorithms to search for patterns, correlations, and unique linguistic structures that might encode deeper information. One compelling area of research involves the analysis of Vedic descriptions of cosmology and their alignment with modern astrophysical data. Scholars are not literally looking for mentions of black holes or neutron stars. Instead, they are examining the structural and qualitative descriptions of cosmic processes. For instance, the detailed accounts of cyclical universes, cosmic dissolution, and the vibrational nature of reality are being compared to modern theories like conformal cyclic cosmology and the quantum nature of spacetime. Researchers use natural language processing tools to break down the Sanskrit verses, analyzing the semantic relationships between words describing creation, destruction, and sustenance. The goal is to see if the logical and relational structures embedded in the language itself reflect a cohesive model of the universe that is internally consistent and, in its own way, compatible with the external consistency we observe through telescopes and particle detectors. Another intriguing line of inquiry focuses on the physics of sound and vibration, central to the Vedic concept of Nada Brahma. Acoustic scientists and physicists have conducted experiments analyzing the precise sonic properties of Vedic mantras, particularly the Gayatri mantra and the syllable Om. Using advanced spectrographic analysis, they have studied the frequency patterns, harmonics, and resonance effects produced when these mantras are chanted correctly. The findings often point to these chants producing highly ordered, coherent sound waves with a unique ability to influence the immediate environment and the psychological state of the chanter. Some researchers draw parallels between these structured sound patterns and the concept of cymatics, the study of visible sound and vibration where specific frequencies create intricate geometric patterns in materials. This lends a tangible, physical dimension to the ancient idea that sound Chinese letter can structure reality, offering a potential, albeit metaphorical, bridge to the vibrational strings of superstring theory. Perhaps the most direct, albeit controversial, attempts at validation concern energy and consciousness. Some studies, often falling under the umbrella of what might be called consciousness studies or bioenergy research, have tried to measure the physiological and environmental effects of practices derived from Vedic knowledge, such as meditation and pranayama or yogic breathing. Using EEG machines to monitor brain waves, infrared cameras to study thermal changes, and even sensitive magnetometers to detect subtle magnetic field fluctuations, researchers have documented significant alterations in subjects engaged in these practices. The reported effects include increased coherence in brainwave patterns, improved regulation of the autonomic nervous system, and even localized changes in ambient energy fields. While mainstream science often views these studies with skepticism due to challenges in replication and control, proponents argue they provide empirical evidence for the Vedic concept of prana, a subtle energy that animates matter, and its potential interaction with the physical body and the environment. This line of research, while contentious, pushes the boundaries of how we define energy and its relationship to consciousness, a frontier where ancient insight and modern inquiry seem to be slowly converging on a shared, albeit elusive, territory. Of course, such a profound reimagining of ancient texts does not come without its fierce and necessary critics. It is absolutely crucial to step back from these awe-inspiring parallels and examine them with a healthy dose of scientific and historical skepticism. The primary charge leveled against these interpretations is a logical one, the argument of retrofitting. Skeptical historians and scientists argue that we are not discovering pre-existing knowledge of anti-matter in the Vedas. but are instead projecting our modern understanding onto ancient poetry, selectively cherry-picking phrases that seem to fit while ignoring the vast majority of the text that clearly does not. It's a form of confirmation bias on a grand scale, where we see what we want to see in a Rorschach test of vague and symbolic language. Consider the concept of a sat and its pairing with sat. A scholar of Sanskrit literature would rightly point out that these terms are deeply rooted in a philosophical and ritualistic context, not a scientific one. A sat often simply referred to the unmanifest potential before a ritual sacrifice, which would then be made manifest sat through the correct performance of the ceremony. To leap from this to the quantum vacuum is an enormous conceptual jump that the original composers almost certainly never intended. The same applies to the poetic descriptions in the Nasadiya Sukta. Its beauty and profundity are undeniable, but its language is intentionally ambiguous and paradoxical, designed to inspire spiritual wonder, not to outline a physical theory of cosmology. A skeptic would argue that its verses are so open-ended they could be made to fit almost any modern scientific theory, from the Big Bang to multiverse theory, simply because they don't commit to any specific mechanistic details. From a scientific standpoint, the criticism is even more pointed. Science operates on a specific methodology, forming a hypothesis, making a prediction, and then testing it through repeatable experiment. The interpretations of Vedic texts do none of this. They offer post-dictive explanations, not predictive tests. No one used the Rig Veda to calculate the mass of the positron before it was discovered. The connection was only made afterward. This is the opposite of the scientific process. Furthermore, if these texts truly contained a working knowledge of particle physics, even in allegorical form, one would expect that knowledge to have led to some form of technological application within those ancient societies. Yet there is no archaeological or historical evidence for anything resembling particle accelerators or energy systems based on annihilation. The knowledge, if it was there, remained entirely abstract and without any practical outcome for millennia, which strains credibility. Many academics view these interpretations as a form of modern myth-making, often driven by cultural nationalism or a well-intentioned but misguided desire to find validation for ancient wisdom in the language of modern science. This can unfortunately lead to a dismissal of the actual, incredible achievements of these cultures, their real advancements in mathematics, astronomy, and metallurgy, in favor of pursuing far-fetched speculative connections. The precise calculation of pi or the accurate prediction of eclipses is, in its own way, more impressive and verifiable than a debatable poetic allusion to quantum fluctuations. So where does this leave us? It creates a necessary and productive tension. The skeptical perspective acts as an essential guardrail, preventing us from veering into unfounded fantasy. It forces us to be precise, humble, and rigorous in our comparisons. It reminds us that the primary value of the Vedas is spiritual, philosophical, and cultural, and that value is not diminished if they are not also secretly textbooks of quantum mechanics. However, this skepticism should not be used to completely shut down the conversation. The sheer volume and specificity of the parallels, from the numerical codes to the conceptual models of cyclical creation and destruction, are at the very least remarkable coincidences that deserve a thoughtful look. Perhaps the most balanced view is to see the Vedic rishis not as physicists but as profound metaphysicians. They were mapping the terrain of consciousness and reality from the inside out, using the tools of introspection and revelation. In doing so, they may have stumbled upon archetypal patterns and fundamental truths about the nature of existence that our external science is only now beginning to quantify. Their language is one of metaphor and symbol, and while it should not be conflated with scientific fact, it may operate as a different, parallel path to understanding the same profound mysteries that captivate us today. So, after this incredible journey through time and thought, where does this leave us? We've sifted through ancient hymns that describe a void teeming with potential, explored philosophical systems built on dynamic dualities, and decoded myths that seem to narrate the annihilating embrace of matter and its shadow twin. We've seen how the Vedic concept of a sat and sat mirrors the quantum vacuum and its virtual particles, how the struggle between devas and asuras allegorizes the creation and destruction of particle-antiparticle pairs, and how the radiant energy of tejas finds its physical counterpart in the gamma-ray flash of total matter-antimatter conversion. The parallels are not just occasional, they form a pattern, a tapestry of interconnected ideas that span millennia. What do these connections truly mean? They don't mean that ancient sages had particle accelerators hidden in Himalayan caves. Instead, they suggest something potentially more profound, that deep, introspective exploration of consciousness can arrive at fundamental truths about the nature of reality that external, experimental science is also working to uncover, just using a completely different language and methodology. The rishis were mapping the cosmos from the inside out, using the tools of meditation and heightened perception. They described the universe not in terms of quarks and leptons, but in the language of mythology, symbol, and spiritual experience, a language of metaphor that seems to point toward the same underlying principles our mathematics and machines are now confirming. This isn't about one culture being more advanced than another. It's about the fascinating possibility that humanity has always had access to deep wisdom about the cosmos, expressed in different dialects of understanding. This invites a radical shift in how we view ancient knowledge. We can no longer dismiss these texts as mere mythology or primitive superstition. They represent a sophisticated and coherent system of thought, a science of consciousness that developed a profound and predictive cosmology. Their value isn't diminished if we don't find the exact mathematical formula for a positron in a Sanskrit verse. Their value lies in the holistic, interconnected vision of a conscious, vibrational, and dynamically balanced universe they offer. This perspective doesn't replace modern science. It complements it, offering a philosophical and metaphysical framework that can inspire new questions and new ways of seeing the problems we are still trying to solve, like the great mystery of why our universe is made of matter at all. This exploration ultimately blurs the line between the objective and the subjective, between the physical and the metaphysical. It challenges the notion that the only real knowledge is that which can be measured in a laboratory. Perhaps the ultimate nature of reality is something that can be approached from multiple angles through the external observation of physics and the internal exploration of consciousness. The Vedic seers and modern physicists, though separated by thousands of years and vastly different tools, appear to be converging on the same astonishing conclusion, that the universe is a vast, interconnected web of energy and information, a cosmic dance of creation and destruction held in a delicate, mysterious balance. Now we want to hear from you. This is a conversation that stretches across time, and your perspective is a vital part of it. What do you think about these astonishing connections? Do you see them as meaningful parallels or simply as fascinating coincidences? Have you encountered other examples of ancient wisdom that seem to predict modern discoveries? Share your thoughts in the comments below. Let's get a real discussion going. And if this journey into the crossroads of science and spirituality fascinated you, be sure to give this video a like and subscribe to the channel for more deep dives into history's greatest mysteries. Remember to hit the bell icon so you don't miss our next exploration. Thank you so much for watching, and we'll see you in the next